Awesome. Hey, everybody. Welcome to the second day of Soroban Learn Week. Today, we're going to be drilling down into one of our all-time favorites, the Crowdfund Dapp. Now, if you're just joining us or just joining us along in your Soroban development journey, let me give you a little bit of a background on this Crowdfund Dapp. It is our Soroban example Dapp, one of the first Dapps that we deployed on Soroban, and it has been with us throughout each release, and we've been updating it and keeping it current. So I'd like to give a special shout out to an engineer, Paul Bellamy, for creating this Dapp and giving us a solid foundation of Dapps to build off of. So here's our introduction slide, and let's just go over an overview of what we'll be covering today. We'll be covering how you can develop, test, and deploy a smart contract for crowdfunding. Then we'll dive into the components behind the Dapp. And then last but not least, we're going to launch the Dapp on FutureNet, and then we're going to deploy it to a Vercel instance so everyone in the chat can start interacting with it. All right, and here are a few questions that we're going to answer today. What is crowdfunding? And then we're going to answer some questions about how the smart contracts function. So let's go ahead and get to our first question. What is crowdfunding? So when a project wants to hit the market, they typically have a couple of ways they can achieve funding. They could maybe shop a pitch deck out to VCs, or they can rely on the community to help bring their project to deployment. So in a crowdfunding aspect, usually a base of users will either donate or participate in another funding mechanism, whether it be debt-based or reward-based, to help fund a project and get them off the ground. Now, I have a couple of examples here. Gitcoin is a Web3 kind of platform that allows blockchain projects to ask for funding and grants, and the community can go and start funding those. Rhenium is an interesting protocol because they actually crowdfund climate projects. So as an example, if I wanted to start a solar farm in, say, Colorado, and I needed $100,000 to do so, I could rely on the community to help fund that. Once I start generating these things called renewable energy credits, I could sell those on the market, and my funders would then get a share of those returns. Next up, we have some classics here. Kickstarter, a popular crowdfunding platform for projects looking to get their project deployed and off the ground, usually seen with startups. And then we have GoFundMe, which is usually for charity and other kind of humanitarian-based donation campaigns. And last but not least, we have Indiegogo. This is an interesting protocol because it allows creatives to fund their creative projects, such as albums, art deployments that they want to do, NFT fundings, etc. So this is just an example of some of the crowdfunding platforms that exist on the market. And next up, we'll go ahead and head right into our crowdfund Dapp walkthrough. So for this, I'm actually going to leverage the Soroban Dapps challenge. I've added a link in the description of the Discord event, but I'll give you a high-level overview of what this is. Here we have a dashboard that displays a couple of the challenges available so far. You can proceed through these challenges, hit progress markers, and then ultimately we'll end up with you deploying a Dapp to FutureNet. So I'll just go ahead and start this challenge. Now, the first step is to clone the repo and install the dependencies. I've already did a little bit of legwork here, so I'll just go ahead and just run this make build docker command to kind of set up my Docker backend. All right, we'll go ahead and let that build. And then we'll just go ahead and dive right into the smart contract and cover all of the awesome functionality that helps this Dapp achieve its crowdfunding target or its crowdfund campaign. So first up, we have this data key, right? So this is going to create a key value kind of storage mechanism here. So we have deadline, recipient, started, target, token, user, and recipient claimed. So each of these is going to serve as the state of the smart contract, and they're all going to come into play later when we try to make deposits and withdrawals. So an interesting thing about this here is that on line 18, you actually see user and then address. So in this key value store, each address is a key, and then the value will be the amount that they deposited. So let's go ahead and keep moving through this. We have our states defined as running, success, and expired. Well, this is going to come into play later when we attempt to make a withdrawal. All right, and then some getter functions. We're simply getting the timestamp, getting the recipient claimed value, the deadline. All of these values that live in the data key, we have getters for them. So to get this value from a key, we're simply going to call this method get, and then we're going to unwrap the value that lives at that key. Next up, let's go ahead and see what happens when we try to get the state. When we're looking at this function get state, we're defining the deadline, the token ID, and the current timestamp. Now, if the current timestamp falls below the deadline, we're going to say, hey, it's still running. If the recipient has claimed the funds within the campaign, or if the target has been reached by the campaign, then we're going to set that state to success. And if the deadline has been reached without reaching the target, we're going to set that state to expired. And here we have a couple of setting functions. So once a user makes a deposit, we're going to assign that value to that key of the user address. So as you can see here, set the user address and the value that they deposited. Next up, if a recipient does claim the funds from the campaign, we're going to go ahead and set this value to true. All right, and here's an interesting function here because we're actually making use of native functionality from the Soroban SDK by calling this token module. So if you look here on line 133, we're creating a client, right? And how are we doing that? We're actually pseudo deploying an interface to a token contract ID that allows us to call specific functions on that address, such as transfer, which is going to transfer the token from one address to another. So let's go ahead and take a look at this module here. As you can see, since this is a trait, it lives on all token deployments on Soroban, and it should as a standard. So this allows you to make cross-contract calls to a token address and really leverage some of the functions that will live elsewhere. This is great because you don't have to import an external function or an external smart contract, such as on Ethereum, where you have to import like an ERC20 or an IERC20 smart contract. This is all built right into the Soroban SDK, and you can build these clients and start leveraging functions that call the token right inside of a function that lives on another contract. So let's go ahead and start covering the functions here. So what happens when you call initialize in the Crowdfund smart contract? So you may recognize these data keys from earlier. We're just simply going to set the values of all these keys to the values that are assigned when this function is called. We're doing a requirement check, and we're saying, hey, if this data key already has a recipient, then it's already been initialized. It's already started. So one thing to note here is that we set get started, or the started key in the data key, as the current timestamp. So once the smart contract has been initialized, this key gets registered as the timestamp at that current moment. All right, moving on, we have some shorthand functions here that are simply referring to the getters from earlier. And then the deposit function. So I want to highlight this functionality here, user.requireAuth. So to make this function successful, we have to have the secret key of the user that we are entering as an argument. Long story short, you have to be the user that is making this call. So what this does is validates that the address user has the proper authorization to make this function happen. Otherwise, I could say something like this, and then maybe enter in a user address that wasn't mine, and then this function would then transfer over tokens from another address. So to mitigate this, we simply say user.requireAuthorizaton, meaning that the wallet that made the call must be the user address. Next up, we have some checks. We're making sure that the amount is above 0, making sure that the state is running. We're defining the token ID, ensuring that the current target hasn't been met. And we're ensuring that the user isn't the recipient. So the person who receives the funds after the campaign is successful cannot make a deposit into their own campaign. Next up, we're saying that we're going to set the user deposited key to the sum of the balance and then the amount that they're depositing. So we're saying get balance, and we're going to define that user's balance by calling this function. And then we're going to go ahead and call that transfer function from the token and transfer it on over from the user wallet to the Crowdfund smart contract address. And then next up, we're going to go ahead and emit some events to the blockchain. Here, we've already created a separate crate that has these predefined events here. So if you take a look at this line here on line number 4, we have symbol new. This is different from symbol short because this allows you to create a string of up to 32 characters long, so long as you pass in this env argument. And this is going to get emitted to the blockchain once we make a deposit. So let's go ahead and deploy this. Let's go ahead and deploy this smart contract to futurenet. All right. And while we wait for that to build, let's go back down here. All right. And last but not least, I want to cover what happens when you make a withdrawal. So here we're defining the state and the recipient by calling this function that retrieves the state, and then we're calling this function that unwraps the recipient value from the recipient key. Next up, we're saying, hey, if this state is still running, then we're going to exit and say you can't make a withdrawal because the sale is still running. If it's been successful, then we're saying, hey, only the recipient may make a withdrawal. So here in this check, we're making sure that the to address is the recipient address. And next up, we're ensuring that the user has not already withdrawn funds. And if they have, we're going to kick back this error saying that they've already done that. And then last but not least, if the deadline has been reached and the target hasn't been reached, then every user who made a deposit can go ahead and withdraw their funds back. So here I'm making a check to say, hey, if you're the recipient, you're not allowed to withdraw the funds because it expired and you didn't meet the target. Next up, we're simply setting the state back to 0. And then we're going to emit the events to the blockchain. Cool. Now that we've deployed that, let's go ahead and take a look at the initialization or the initialize function in action. I'm not going to go too granular in this script here because we already kind of covered that in the first session, but essentially we're setting our endpoint to futurenet, which is going to register the RPC endpoint as such, and then register the Soroban RPC host accordingly. Next up, we're going to create a token admin address to deploy and initialize the abundance token. This is going to be just a random token that we're going to be using throughout this tutorial to demonstrate the functionality of the crowdfunding campaign. So we get that ID here, make sure it's deployed. And then next up, we deploy the crowdfund smart contract here, and we retrieve the ID from that deployment. And then we move on to initializing both the abundance token and the crowdfund smart contract. So initialize in the abundance token means that we're going to define the symbol, decimal, name, and then the admin. So the admin is allowed to do things like mint, burn, set allowances, etc. And it's required to be an argument on certain functions, or the source key is required to do certain things like mint, burn, etc. So here you can see we're initializing it with the symbol ABND, setting the decimal places to 7. So this is just arbitrary. It could be 18. It could be a number that you so choose. But this means that after 7 decimal places equals 1. So 1 would look like 1, 1, 2, 3, 4, 5, 6, 7. So that's 1. If I wanted 100, I could do R10, and then 100, and then 1000. So after 7 zeros, it equals 1. Next up on the initialize command for the crowdfund smart contract, here we're defining the recipient in that data key that we covered earlier, the deadline, the target amount, which is going to be 2,000, and the token that we're going to be receiving. Awesome. Now that we've deployed this onto futurenet, let's go ahead and set up a front end and start interacting with it. All right, so you can see I've already connected to the front end here. I'll go ahead and make sure I'm connected to FutureNet. All right, so I'm logged into FutureNet and I'm on my local development, localhost 3000. I want to point out that we do have a couple of components at play here. If the session is loading, you're going to see that this spinning module pops up until wallet data is retrieved. And once wallet data is retrieved, we then go ahead and populate this form pledge bar. So this form pledge bar is really where all the magic happens, right? We have our mint function, right? So this is gonna mint 100 abundance tokens to my wallet. And we can go ahead and take a look at what's happening here in the form pledge function. So we have handling deposits, and then this is going to update the amounts that the users have deposited. So let's just go ahead and make a deposit here. Awesome. And you can see here that this is going to let us know that the transaction has gone through. This is actually covered by a transaction modal. So let's go ahead and look at this. We're setting a couple states here, right? If the transaction is successful, then we go ahead and return this awesome panel that lets you know that you did a good job and say, hey, thank you for contributing to this crowdfund campaign. And we have our socials here that are defined in the front end. And then we can just go ahead and keep taking a look at all the components at play here. We have this progress bar, which shows the amount that has been pledged to the campaign thus far, and it's illustrated in this awesome blue. If I wanted to, we can go into CSS and change that around. Next up, we have our author info. So we have our avatar, we have the name, and then we have a little bit of data about the author here. Yeah, loading, progress bar, author info. And then let's go ahead and take a look at our campaign page here. So this is where our image comes from, right? If I wanted to get rid of that image or maybe change the image, I would simply modify this line here. If I were a climate project, maybe I would put a video of some drone footage or something to inspire users to fund my cause. And here is the description that we are working with. So hello, my name is Soroban Sam. Hello, my name is Soroban Sam. Awesome. Next up, we have our pledge form. And this is really where all the magic happens, right? So this allows us to do things like depositing and kind of handles all of the logic behind updating the front end and all that. So here's a use subscription webhook where we're simply listening to when the value of the abundance token balance has been changed, and then we're updating that in the form there. Next up, when the target is reached, we go ahead and set the target reached constant to true, and then the state of that form will then change. So it won't look the same, and until we reach this 2,000 abundance token goal, it'll maintain this form. All right, so let's go ahead and just keep on moving through some of these modals here. All right, so here's the form pledge component, and this is where we're making this mint function, or we're calling this mint function. I like to point out that we're making heavy use of the TypeScript bindings here. So we're importing anything from the abundance node module. And if we take a look here, here's where the functions of the abundance token is defined. So if I just do a quick search for mint, it's all defined here through the tool Soroban contract TypeScript bindings. And this generates the ability for us to leverage TypeScript syntax in our front-end components. So let's go ahead and head on back to where we were. All right. So once this is complete, then we're going to go ahead and update the displays. So let's go ahead and just do another mint here. As you can see here, my balance is updated from 0 to 100, and then we can do another deposit. And again, this is ensuring that I have the keys to the address that I'm making the request from. Since we're calling user.requireAuth, I have to be the signer of this function. All right, so that's a little bit about the components that exist here. Let's go ahead and see what this looks like when we deploy it to an instance of Vercel. So if you're not familiar with Vercel, they actually offer a CLI tool that enables you to do deployments of your project. So I've already built a project previously around this, and I'm just simply going to update this by deploying it to npx Vercel. I highly recommend using this tool when you're trying to get through, or when you're trying to reach a production level illustration of your project. It's a really, convenient tool to use, especially because it comes in the form, and especially because it's provided in the form of a CLI tool. We simply have to call these commands, walk through a couple steps, it begins building, and then it's deployed right to Vercel. So once this is done building, I'll have a URL I can go to on the internet, and then we can start making our own deposits and withdrawals potentially. So we'll go ahead and make this, or we'll go ahead and wait for this to build. I'll simply copy this over, go to a new tab. Awesome. So this is actually a site that exists. I'd like to share this with the chat here, so I'll just go ahead and share it where I'm at. And you can actually start minting tokens, and you can start making deposits and start funding this crowdfund campaign. So let's just make sure we're not localhost. As you can see, we're on a Vercel instance. I'll go ahead and mint myself some tokens. And then I'll go ahead and back this project 100. Awesome. So again, this site is actually live. You can go to it now. You can start minting tokens, and you can start funding this crowdfund campaign. Now, I'd like to go ahead and spin up a local instance one more time, and then we can go ahead and just start messing around with some CSS. All right, so this is a page on my local host, and you can see it's been updated with the amount that we just pledged, so that's great. And let's go ahead and just take a look at what we have here. So we got this form pledge. If I wanted to mess around with this and customize it a little bit, I could make this a column. If I wanted to make these buttons a different color here, I could go like this. Buttons. And you go to like an orange, right? And if I wanted to go over here, oh, amazing. I see someone has funded us 25 abundance tokens. So thank you for your contribution to Soroban Sam's art crowdfund campaign. Awesome. And then furthermore, we could keep customizing this if we wanted to do something like, amount input. And we wanted to change this background color to like something else. Yep. So you can see that this Dapp is ready to be cloned. It's ready to be interacted with. And if you're looking for a step-by-step guide to help you build this Dapp, then I highly recommend you head over to the Soroban Dapps Challenge for, like I said, a step-by-step guide leading you all the way up to deploying on FutureNet. So that just about wraps up the introduction to your first Dapp. And yeah, I can go ahead and cover any questions, if any.
Thank you so much, Julian. I guess in the meantime, I would like to talk about Soroban once again and kind of just share my screen here. And let's see. Okay, so here we go. So as I mentioned, Soroban Road to Mainnet is live. Connect, Code, Conquer. This is the opportunity to connect with people and to code and conquer the Soroban smart contract ecosystem, right? I want to emphasize that there's plenty of prizes. There's a lot of beginner prizes. It's $10,000 for the first best Dapp. Our focus right now is on Dapps, right? That's why we're even doing this like foundations of Dapp course right now through Jillian or with Jillian. And it's an opportunity for you to really dive into Dapp development and tinker with the ecosystem. So I just want to emphasize that the whole reason we're doing this is so that eventually you get inspired to build a Dapp on Soroban and you're submitting to Sorobanathon, RTM. And we'll be adding more prizes, more honorable mentions as a way for you all to be encouraged to want to build more Dapps, even if you're new to the ecosystem, right? So yeah, thank you all. I think we have one comment here where it says, can you show/comment how to emit the TS bindings from the Rust contract, Jillian?
Yep, absolutely. All right, so I'll go ahead and go into our this deployer here. So I ran this script here, npm run setup. I'll just go ahead and do it again. And it's going to run a script in the background that is build contracts. So first things first, removing previous deployment folders. Then we're going to say Soroban contract bindings TypeScript. Now, there are a couple of other bindings you can generate, but for this, we're using TypeScript. We're going to specify some arguments here, WASM, the WASM file, the ID, which we recorded during the deployment, and then the RPC URL, network passphrase. Going to give it an output directory, and then we're going to give it a contract name. Now, I do know that this tool is being updated. I don't think we're going to need the contract name in the future, but to answer your question, it's used from the Soroban CLI. So you can start using this tool if you install Soroban, like the Soroban CLI, and you have a smart contract. You can go ahead and call Soroban contract bindings TypeScript, pass in these arguments, and it will be built in a folder similar to this. So we can even dive into these a little bit more. I honestly really love this tool because before it, we had to do a bunch of XDR conversions, which wasn't the most convenient way. So we've come a long way since then. And like I said, this Dapp has been with us throughout each release. And we've been adopting different functionality along the way. So this is a really good, convenient way for you to start generating bindings that will help you create these front-end components rather easily, right? It almost emulates something like Ethers.js.
Mm-hmm.
So here's basically where all the functions from the smart contract live. Right now we're in the Crowdfund contract. And then let's go ahead. Oh, sorry, this is the wrong place. Here we're defining the data key. See, it does all of these conversions for us. So we're still making the conversions in the back end, right? And we're still leveraging tools like Soroban Client, but instead of having to do this manually like we were before, we're simply relying on these bindings, and they already have this pre-built in to communicate with the Soroban RPC. So yeah, that's how that works.
Another question. In addition to Freighter, any other wallets devs can play with when prototyping on FutureNet?
Yes.
Yeah, Beans, right? Well, no.
Yeah, absolutely. So this is also a really great question. Thank you for asking. This is something I wanted to cover in this tutorial. However, it was a little bit out of scope. So there's Freighter, but then there's also an awesome wallets kit called CrateTech. CrateTech Stellar Wallets Kit. It's on GitHub, and that allows us to integrate with Xbull, Lobster, and I believe Freighter, possibly Albedo. I'm not sure if it's on that list, but there is another resource, Scaffold Soroban, that actually uses this library. So if you head on over to scaffold-soroban, you can Google it, and then you should reach the page where you start interacting with the dApps. So when you hit the Connect Wallet button, it'll be a pop-up similar to Wallet Connect, and then you'll see various wallets there. Yeah.
Sweet. All right. I think that's all the questions. Thank you all for joining us. Really appreciate it. Once again, stay tuned for the next one, which will be on Friday, right, Jillian?
Yep, exactly, Friday.
Yeah. It's Friday, and that will be our last one for this. And we'll be wrapping up this series and starting off a new series with our partner called Easy A for summer of Soroban. As we're wrapping up the summer, they'll be doing multiple different module challenges, and it's all mobile app based, and it'll be a great way for you to just refresh your Soroban knowledge, and it's also a way for you to earn points for the swag store, things of that nature. Following that, we'll be releasing a docs challenge where we have a little Easter eggs hidden in our documentation, and it's an opportunity for you to go through it, find those Easter eggs, redeem them for points, which equals swag. These are all activities that we have challenges leading up to for you to get excited to go tinker and play with Soroban so that you can build your dApps for Sorobanathon. But yeah, that's a wrap, y'all, for today. We will see you all on Friday. Thank you so much. Take care, everyone. Bye.
Take care.